Hello students. So today we are going to do the remaining part of exercise 1.2. Okay. So question 8. Let A and B be two sets showing that F is from A cross B to B cross A. Okay. This is a set of Cartesian product of A and B such that F of AB is equal to BA is a bijective function. So both we have to show 1, 1 and on 2. Okay. Exercise 1.2 question 8. So function is defined from A cross B to B cross A. Okay. So f of A comma B is B comma A. So let's consider two elements to show 1, 1. Okay. Let f of A1 B1 is equal to f of A2 B2. Okay. So this will be B1 A1 equal to B2 A2. So using the Cartesian product thing, that is property that if the two Cartesian products are equal, x elements are equal and y elements are equal, right? B1 is equal to B2 and A1 is equal to A2. Okay, so we can write this as A1 B1, that is our x, is equal to A2 B2, that is our x2. Okay, this is x1, this is x2. So this is 1, 1. Let's prove for onto. For onto, you have to consider one element from codomain. Okay, let's say B comma A belongs to B cross A. Okay, such that there exists A comma B belonging to A cross B, such that f of AB is equal to B. This is okay. This is already there. So this is onto. Next question. Question 9. Let n to n, that is function from set of natural numbers, be defined by this. Okay, I'll write it. F of n is equal to n plus 1 by 2. N is odd. N by 2 if n is even. Okay. So to prove 1, 1, first you take one element, say n equal to 1. So this becomes your odd, right? So you have to use this definition. So f of 1 is 1 plus 1 by 2, which is 2 by 2. 1. Okay. Let's take n equal to 2. So this is even. So you have to use this definition. 2 by 2. So it is 1. Okay. So from this you can say that 1 is going to 1 and 2 is also going to 1. So this becomes many 1 and not 1 1. Okay, it is not 1 1. Next we have to prove for onto. So we got that 1 is going to 1, 2 is also going to 1. What about 3? 3 is odd, right? 3 plus 1, 4. 4 by 2 is 2. It goes to 2. And what about 4? 4 also goes to 2. 5 goes to 3. And 6 also goes to 3. So all numbers are covered. all the numbers in the codomain are covered, right? So this is actually onto. So when you take n odd, you get f of n to be odd. Okay. And when you take n even, again you are getting odd. No, it depends upon the number. That is, if it is 2, if it is 3, 3 plus 1 by 2, so you will get 2. That is, you are getting, every time you are getting a natural number. And the images are distinct, right? So theory wise, you can write that if n is odd number is written as sum to p plus 1, right? Where p belongs to a natural number. So you'll get some, there exists some, so p equal to 1 if you put, you'll get 2 plus 1, 3. Or you can write, okay, you can write like this. F of n equal to some y. Okay, n plus 1 by 2 equal to y. So n plus 1 is 2y and n is equal to 2y minus 1. This is for odd. And for even, you can write f of n equal to n by 2 equal to some x. So n is equal to 2x. This is for where y belongs to n and x belongs to n. This is for even. Okay. Next question is, let A said be R difference minus R difference 3 and B is R difference 1. Consider the function. Okay, this is f1 1 and on to justify your answer. First we will go for 1 1. So f is from R difference 3 to R difference 1. Okay, and f of x is x minus 2 upon x minus 3. Why 3 is removed from this domain? Because if 3 is there, then you will get here 0. That is, denominator is 0. So it becomes infinite. That's why 3 is removed. Okay. So for 1 1, let x1 x2 belongs to R difference 3. So f of x1 is equal to f of x2. So x1 minus 2, x1 minus 3 is equal to x2 minus 2, x2 minus 3. Okay, cross multiplying will get x1 minus 2 into x2 minus 3 equal to x2 minus 2 into x1 minus 3. Okay, multiply. So we'll get x1 x2 minus 2x2 minus 3x1 plus 6 equal to x1, x2, 3x2, 2x1 plus 6. Okay, 6 and this x1, x2 gets cancelled. And you will get 2x2 minus 2x2 minus 3x1 minus 3x2 minus 2x1. Right? Yeah. Minus you can take outside. Or can rewrite this. That is, you can take x to that side. Okay. So this will be minus 3x1 plus 2x1 equal to minus 3x2 plus 2x2. Okay. So now you can take x1 common. So this is minus 3 plus 2. That is, you can directly add them, right? So this is minus x1 minus x2. So x1 is equal to x2. So this is 1, 1. Okay. Now let's solve for onto. For onto, you have to take this f of x is equal to y. Okay. So let some y belongs to r difference minus 1, 1. Okay, such that f of x is equal to y. So f of x is x minus 2 upon x minus 3 equal to y. Multiplying, you will get xy minus 3y. Okay. So take this x term this side. And 2 term that side. So you will get x you can take common. So 1 minus y equal to minus 3y plus 2. So x is equal to 2 minus 3y upon 1 minus y. Okay. So because of this, they have given r difference 1. Okay, 1 is removed. If 1 is not removed, this becomes infinite. Okay, so this is for any y belonging to r difference 1. There exists this x, that is 2 minus 3y 1 minus y, such that f of x is equal to y. Okay, so this is onto. Question 11. Let f r to r set of real numbers be defined as f of x equal to x raised to 4. Choose the correct answer. That is, we have to check whether it is 1 1 on 2. Okay. So this is actually same as the x square type. Okay. X equal to x square. X raised to 4. Okay. So f of 1 is going to 1. F of minus 1 is also going to 1. So 1 and minus 1 both are going to 1. So this is not 1 1. Okay. What about onto? So onto also it is not possible because every number is going to a positive value. Negatives are left. So if I choose some minus 2 belonging to r, there does not exist any x belonging to r such that f of x is equal to x raised to 4. Okay, because this side is all positive numbers. This side it is all positive numbers. What about negative numbers? Negative numbers are not covered. So this is not on. So it is neither 1 1 not onto. Okay. Next question is, let f from R to R be defined as f of x equal to 3x. So in this textbook it is, we have, correct answer is this. Okay. R to R is defined as f of x equal to 3x. Again you have to check for 1 1 and onto. Okay. Here the major part is you have to look for the sets which are given. If it is real number, then all the numbers are there. If it is natural numbers, only the positive numbers are there. Okay, then you have to go for the function to check 3x. So to prove 1 1, so let say x1 x2 belongs to R such that f of x1 is equal to f of x2. So 3x1 is equal to 3x2. So x1 is equal to x2. Okay, this is 1 1. What about onto? So let's say some y belongs to R and there exists some x belonging to R such that f of x is equal to y. So 3x is equal to y. So x is equal to y by 3. Okay, and this belongs to R. So it is onto. Okay, it is both 1 1 and onto. So the correct answer is first one. No, yeah, f is 1 1 onto.